For this video, we'll use Emporium Towers as an inspiration to create a 3D model using Grasshopper. The model will be fully parametrical, which will enable us to easily tweak and modify it as per our preferences with a few simple sliders. You will learn how to create facade extrusions to get a rhythmic effect following the shape logic. In this process, we'll define position of the point attractor first, and based on its position, the overall rhythmic appearance of the facade will be modified. So let's get to it. First, we'll create a line using as the align component. It requires 3 different input point, direction, and the length. First, let's create a starting point, right click, set point. For the direction, I will use a unit X. The length we can define 30. If you want to change direction, you can rotate this vector using component rotate. Here we need to set axis of rotation, which will be unit Z. Set the slider from 0 to 360. Place in the angle, but don't forget to set degrees here. So right click and check degrees. We'll have this sign for degrees, and now I will place in the direction. And if I change this slider, we can rotate on the line. Now I'm going to multiply this line along a Z axis. So I will use component move. For the vector, I will set unit Z, and in the unit Z, we need to set series of number. I will use component series, place in the unit Z. We need to define 3 different inputs, starting point in the series, then spacing between the numbers, and then how many values we're going to have in the list. I will keep a starting point 0 by default. For the spacing between the numbers, I will set 2.4. That will define the floor height. And here we can define how many floors, or in this case, how many lines we're going to have. And let's say 36. This is totally random. Once we create a list of lines that we have here, I will extract their middle point using component curve middle. We need to find a way how we can extract one point from the list. So for that, I'm going to use a list item. So I'm going to take the value which represent the number of the lines in the list, and I'm going to subtract by 1. So we'll use expression. And here I will type x minus 1, because this is the maximum index number, 35, when we can have a look here. So if we scroll down, 35 is the maximum index number. And this number I'm going to multiply with the value from 0 to 1. You can see if I modify this slider, we can select 1 point from the list. Once we extract single point, I will calculate the distance from that point to all the points from the list. And here we have the list of distances. So our idea is to take this attractor point, which is placed here, and I want to calculate the distances, which we did here. I want to take the line which is closer to the attractor point, and I'm going to divide with the most division points. It will have the most divisions, and the line which is furthest from the other point will have smallest number of divisions. Let's say just 2 divisions or 3 division points. So the line which we can see here placed at the index 25, we are going to divide with the largest number of divisions. Let's say we will have 18 divisions, then 2 neighboring lines will have 17 divisions, then the next one will be 16, then the next one will be 15. And you can see the number of divisions will decrease by 1 once we reach index 0. In this case, because this is the largest distance, or this line is the furthest from that point, it should have the smallest number of divisions that we're going to define. This will have 4, which will represent smallest number of divisions. Or in our case, we're going to use this to construct target domain. And one more thing what I want to emphasize. So we need to know what is the maximum number of divisions if we set the smallest number of divisions 4. We can see how many different values in the list we have, and using component create set, we can calculate the list length of these numbers, and it will show us how many different values we have. That number we are going to use to construct domain from 4 to that number. Why minus 1? Because 4 is included in that list. Let me explain what I mean. I will use component remap numbers because we need to remap this list of values. And for the source domain, I will use minimum and the maximum number in the list with the bounds component. Now, if I take number container, I will convert this text into numbers, and I will use create set. In the S output, we have unique numbers in the list. So you can see that we don't have repetition numbers as we have in this list, 2.4, 4.8, 7.2, and so on. Now we can use a list length to calculate the list of unique values or the unique distances, which in our case is 26. Now we can construct domain 26 is the number of this list, and if we start from 4, we need to know the maximum number in the list, how we can get that value. I'm going to sum these two values. I will get number 30, but because 4 is included in that list, we'll use from 4 to 29. And to get that values, I will use expression x minus 1, remove y input, place it here. We'll have domain from 4 to 29, place in the target domain. And now let's use these values to place in the number of divisions, divide curve. Curve to divide will be the lines. You can see now that the line which is closest to the attractor point, this one here, has the smallest number of divisions, 4 divisions and 5 points. But I want to reverse that. I want to have the line which is closest to the attractor curve to have the most number of divisions, so we can simply just switch these two inputs. Once we get division points, we'll take every second point in the list and we are going to move along normal vector and we can create a polyline. The problem will be if we have even number of points. If we have even number of points, like we have here, and imagine this is the line. So we take every second point and we move along normal direction. This polyline here will not be finished at the end of the initial line. We'll have this gap here. If we have even number of segments and odd number of points, we don't get that issue. Once we get the line, I will take the end point and create the line by 45 degrees. Here is 45 degrees. And I'm going to use to mirror it on the other side, and we can create another facade. Once we create two different facades, I will take these two lines, or one of these two lines. Once again, 45 degrees. So here is a 45. We can create the line on the another two facades as we have here. But if we have something like this that I mentioned with an even number of points and the line is finished like this one, once we do the same logic as we did previously, here we'll have a gap. I'm going to take the list of points and I will add one more point here. So basically I will take the last point in the list and I will move it by the same distance that we have between all the points in the list. Now we can create the polyline. And that polyline will be trimmed with the line which is constructed from the end point by 45 degrees. Once we trim this red polyline with a yellow line by 45 degrees, we'll get ending point. This part we're going to remove and the rest we'll keep. You can see it here. Once we keep the rest, we can use the same logic, 45 degrees, we can mirror it and also mirror it on to other sides. Here we have the number of divisions and how we can distinguish which are even and which are odd. So for that, we can use modulus. So I will connect it here. And for the second number per modulo, I will type 2. And here we get numbers 0 and 1. If we get 0, that number is even. If we get 1, that number is odd. And I will use this as a pattern. So I will use shift pattern, place here. And list to shift will be a list of points. I forgot to graph this one. So in the 0, we have the list of points that are placed on the line with the even number of divisions. So I'm going to keep them unmodified, but the output of the points from the 1, we need to add one more point. So first we need to define the spacing between each neighboring point in the list. So I will use here 0 and I'm going to extract. So here we have 0 and 1. And let's create a vector. Okay. And now I'm going to move point. Here we have the list of points. Use one of these, the point with the index 0. So this one here. So you can see that I move on the wrong side. So simply we can just switch to these two inputs. And once we create additional point, so I will use merge component. I will take this one, I will place in the D1, and in D2 I will place the rest of the points. So, and once we add additional point, I will place this back in the list of points from here. So I will use combine data. This is 0, this is input 1. Now let's create polyline, but I will need to extract every second point in the list and move along normal vector. Once again, I will use shift pattern. Here the pattern will be 0 and 1. So 0 and 1. Place it a P. points from the 0 I'm going to keep, but points from the 1 I will move along normal vector. Normal vector is something like this. How we can define normal vector? Using cross product. In the A will be the vector that we use to create SD line, and the second vector will be unit Z. This is very simple how we can create normal vector. I'm going to place in the move, but before that we need to define the amplitude for how much we want to move the points. Now I'm going to add amplitude. So here we can define for how much we are going to move every second point in the list. This list of points is okay. And you can see the issue that we have here. Let's focus on the bottom line. These 2 points that looks like 2 neighbor points are moved, but this is not what we want to get. The problem is that I didn't clean 3 here. So if we take a look here, I didn't clean 3, and this null is added in the list. So instead of having 4 nulls, we have 5 nulls because of this one. So we need to clean 3. And now we don't have any nulls. And look here, once I connect, now we have 4 nulls. And let's move it back. Take a look. Now we don't have 2 neighboring points that are moved along a normal vector. Once we move the points, we can place them back using combine data. And let's create a point line. Now we need to extract endpoints, these guys, and we need to construct lines by 45 degrees in order to trim the unnecessary part of the point line. So let's use endpoints of the lines. Let's go back here where we create a line here. So let's extract endpoints. I will place all starting point in the branch 0 and points in the branch 1. And I'm going to use this to create as the line. Now we need to set the direction we can take if we use the vector or the normal vector. Let's take this one here. And I want to rotate by 45 and minus 45 degrees. Why by 2? Because I want to create here lines like this, and on the other side lines like this one. Here we have the vector, and I'm going to rotate this vector. Axis of rotation will be unit Z, and the angle will be minus 45 and 45. Don't forget to check degrees, place in the SDL graph, and you can see how we manage to create the lines that we need. Also, we need to create the length, and the length can be taken from here. So let's use the amplitude, and we can multiply, let's say 5. And I will set in the L of the SDL line. Here we have the list of lines, here we have the list of point lines. So I'm going to flip matrix, because I want to get 36 branches, the same data structure as we have here. And now let's use a component curve intersect with the curve, and let's use shatter. This is the curves that we want to trim, curve in the A, and we get error. So why we get error? Because of the different data structure. We should get 36 branches, but here we get 72 branches. We can simply use trim 3. And now we get 36 branches. I'm going to place it here. In each branch, we either have 1 or 2 items. Now let's sort the items based on their length. Reverse the list because by default it's set to ascending order, and we get the list of point lines. In the next step, we need to take all these point lines, and we're going to mirror it. If we create here 45 degrees, and based on this vector, we'll create a plane. Let's go back here where we created SDL line, and I want to extract 2 endpoints. Okay, and I want to find this point. This point will represent origin of the plane. So let's construct plane. Axis of the plane will be this one here, so by 45 degrees. So basically we need to take the vector, and I want to rotate by 45 degrees, and the vector is the one that we created here. So let's take this vector, and I want to rotate this guy by either 45 or minus 45. Let's have a look. Degrees, and the axis of rotation will be unit Z. This will be X plane. and Y will be Z. Let's have a look. Mirror. This is the plane that we're going to mirror. This is the mirror plane, and this is geometry. We managed to create first facade. Now I'm going to merge these two set of polylines, and I'm going to mirror using this point here. This will be origin of the plane, and once again we can create plane which is rotated by 45 degrees. Let's extract another point, and in this case it will be rotated by minus 45 degrees. So once again, construct plane. This will be the origin, this will be the X. And now let's use mirror. And this is the geometry to mirror, and this is the plane. Now let's merge these two set of polylines, and you can see that in each branch we have 4 polylines. Join them. If I use boundary surface, we can create slabs, and if I use extrude, I can extrude along Z-axis, and the value for the extrusion will be the one that we define here, which is 2.4. And here we get final geometry. Here we can change the position of the attractor point, or we can change the side how these extrusions will appear. If we reverse the list, the extrusion will be inversed on another side. And also we can change the number of divisions, and of course we can change the number of floors. In the extended video you will learn how to use a looping plugin called Anemone to orient a single facade on all 4 sides of the tower. We will also touch upon how to generate facade balconies and how to unitize glass surface orientation that might be helpful for improving your Grasshopper skills. In addition to that, the extended video will also cover how to add further details such as railings, glass division based on surface area, and glass frames. You can get access to the extended tutorial on our Patreon page, and with that you will also get access to all of our other extended tutorials and project files. The link is in the description. If you'd like to know exactly how to create complex projects like these, and if you're interested in step-by-step learning approach starting from zero, make sure to check our Grasshopper Complete course, where you'll find over 60 hours of video material structured in a form of video library, covering in depth more than 500 Grasshopper components through practical examples. And you'll have access to us personally, so we can answer all of your questions right away. The link is in the description.